Nitrous oxide may be an invisible gas, but it can have significant impacts on our environment. Sometimes called laughing gas, nitrous oxide is no laughing matter. It's a powerful greenhouse gas that's over 300 times stronger at trapping in heat than carbon dioxide. And it's a pollutant that damages our ozone layer. Agriculture Victoria scientist and project leader, Professor Roger Armstrong, explains.
Low nitrogen fertilisers are an essential part of most Australian grain production systems. Our research has shown that nitrous oxide emissions are a function of both the rate of nitrogen fertiliser applied as well as the background soil mineral N levels. In some situations, we're adding considerably more nitrogen than the crop needs. Unfortunately, there is increasing evidence that the relationship between nitrous oxide emissions and increasing nitrogen input is an exponential rather than a linear relationship for most crop types. But the good news is, by having a better understanding of how much soil mineral nitrogen is present at sowing, and by some fine tweaking of when we apply nitrogen fertiliser during the crop, we can both simultaneously reduce nitrous oxide emissions, improve grain yields and quality, all whilst saving money on fertiliser.
So that's why the race is on to better understand how nitrogen fertiliser can be better managed whilst finding cost-effective ways to reduce nitrous oxide emissions. Agriculture Victoria research scientists have been at the forefront of research into nitrogen fertiliser management and nitrous oxide emissions in Victoria's cropping industry for over a decade. A variety of field experiments have been established on farms across Victoria's cropping zones to help better understand the issue. Professor Roger Armstrong explains some of the key Victorian research findings.
Overall, we found that nitrous oxide emissions are quite low in low and medium rainfall areas, particularly if nitrogen isn't applied when there's periods of temporary waterlogging. The key thing is to remember nitrous oxide emissions are closely tied to waterlogging events. Other key risk factors that result in higher emissions are high levels of labile soil carbon, high levels of existing mineral nitrogen and warm soils. In the high rainfall zone of southwestern Victoria, we found that larger amounts of nitrogen fertiliser applied at sowing resulted in losses of up to 85% of the nitrogen applied. Effectively, what this means was that applying nitrogen fertiliser in these situations was both a waste of time and money. The good news, however, is that we have some pretty solid rules of thumb for best management practices for fertilisers. The best way to remember these rules of thumb are the 4 R's: getting the right product, the right amount, getting the right timing, and the right placement.
The right product. First of all, non-fertiliser derived nitrogen, originating from sources such as via legume rotations and crop residues, is an important source of N to crops and should be accounted for when planning fertiliser N applications. Consider if nitrification inhibitors, which slow the conversion of ammonium to nitrate, are financially justifiable for your situation. The right rate. The higher the rate, the greater the likelihood of emissions. So make sure you test your soils to determine both the existing mineral nitrogen content and then allow for the amount of soil nitrogen that could be mineralised during the growing season. Once you have estimated the crop's nitrogen demand, subtract the measured nitrogen supply from the soil via your soil test and the estimated nitrogen supply from your soil via mineralisation to determine the nitrogen fertiliser rate you need to apply. Also, check that other factors such as nutrients or disease aren't limiting your crop's growth and ability to utilise any extra nitrogen applied. This is where precision cropping techniques such as variable rate technology, pH mapping, and disease assessments such as PredictB can help get more accurate fertiliser application and avoid wasting inputs that aren't needed. The right time. Match your timing of fertiliser application to coincide with your crop's changing demand. Split applications improves crop nitrogen uptake. but always avoid applying fertiliser when soils are waterlogged. The greatest demand for nitrogen by your crop normally occurs around mid to late tillering, so factor this into your fertiliser management program. The right place. Don't forget to make sure you've checked and measured the accuracy of your fertiliser spreader and operator, and avoid double ups and drainage lines, unless you want to watch money go down the drain. Use the best technique for placing nitrogen fertiliser in the right place that maximises crop nitrogen uptake. Generally, it's best to place your nitrogen into the soil. This helps to ensure nitrogen is more accessible to the crop roots, because crops can't access nitrogen if it's stranded in dry topsoils. It also tends to reduce losses of nitrogen from some soils. There is a potential for even greater losses of nitrogen through volatilisation of top-dress urea on highly alkaline soils such as soils in parts of the Wimmera and most of the Mallee. Remember too that improved surface drainage, minimal tillage and controlled traffic practices also help by improving soil structure, resulting in better grain yields, whilst reducing nitrogen losses occurring during waterlogging. If you're converting pasture into a cropping phase, avoid long periods of fallow, especially in high rainfall areas and if irrigation is used. Short fallows reduce the risk of high nitrous oxide emissions that result from the build-up of high background concentrations of labile soil carbon and mineral N that occur during the decomposition of pasture residues. Future research into nitrogen use and management is continuing to ensure Victorian farmers can not only reduce greenhouse gas emissions, but also ensure fertiliser costs are minimised.